Looked at quadratic equations. We looked at the solution of quadratic equations, how to solve quadratic equations. We looked at how to solve quadratic equations, and then we said there are different methods of solving quadratic equations. We did talk about the factorization method. We also looked at we talked about the completing the square method, and then we chose to deal with the formula method. And the reason we did that was because we won't be able to deal with all the methods considering the time we had. And then the formula method is the best method to use because it is non-selective and it is just straightforward. All you need to do is to recall the formula to use. So for the formula method we looked at that day, we said um, the formula method is given as s is equals to minus b plus or minus the square root of b squared minus 4ac over 2a. So this was, and what we did say was the formula method. This formula method, that's what you guys usually call almighty formula. And we talked about the reason why people call it almighty formula because it is non-selective. Unlike the factorization method, that there are some questions that you can't factorize, so factorization method will not be able to solve those quadratic equations. So unlike those ones, the formula method or the almighty formula is not selective. It can solve any quadratic equation you attempt to solve using it. So that's why people nicknamed it the almighty formula. So that the preceding class we looked at just basic quadratic equations and how we can solve to get of the value of the unknowns. So today we're still looking at the quadratic equation, but we're looking at complex questions involving the quadratic equations. That's questions that would involve roots, questions involving roots in quadratic equations. So they are usually called radical equations. They are still quadratic, but they are radical quadratic equations. So you have to improvise to get the values that you need. So let's say this first example now. If you're told to solve the equation, let's say y minus 11 root y plus 24 is equals to 0. So now this is the equation y minus 11 root 4 plus 24 is equals to 0. So normally the general form of a quadratic equation has to look this way: as to the power of 2 plus es plus c equals to 0. But looking at this question we have now that we've been told to solve, you'll see that it is not in the form of a quadratic equation, but yet it is quadratic, but it is not in the form of a quadratic equation. So this question is radical. So what then do you do such that this radical question is now turned into a proper quadratic equation? Here you would have to improvise. You have to, so you would have to improvise. Please, can everyone hear me well? Okay. All right. So here you would have to improvise by saying that because obviously, as you can see, this doesn't look quadratic. For a quadratic equation, you are supposed to have a power of 2. But look at that, there is no power of 2. The highest power you should have in quadratic equation should be the power of 2. There is no power of 2 there. And then, so now you improvise. You see that, remember, this is the form the quadratic equation has to look like. So you will say that let, you can say let m stands for this your root y, because you're not supposed to be having a root there. So let m stands for root y. Yeah. So if m as it is there, if m stands for root y, then you should know that m to the power of 2 will be equals to y. Does everybody know how I got m to the power of 2 equals to y? If m is equals to the square root of y, does everybody know how I got m to the power of 2 is equals to y from that statement there? Okay, all right. All right, so we'll have to deviate from this a bit so that I can explain to you how. So let us say that you have s squared to be equals to 9 and you're looking for s squared to be equals to 9 and you're looking for the value of s. You guys do know that you have to find the square root of 9. That's s will be equals to the square root of 9. Is everyone aware that when you have s squared equals to 9, that means s is equals to the square root of 9? Is everyone aware of that? Okay, all right. So if you say s squared is equals to 9, means s is equals to 9. So this is something that you can actually, you know, so you can actually reverse. If s squared is equals to 9, then s is equals to square root of 9. Then if you intend to remove that square root of 9 from there, that means you have to give that square root, you have to square both sides if you intend to remove the square root from the 9. Originally, it was s squared equals to 9. So you now decide to remove the square so that you get the value of s. That was how you said s is equals to square root of 9. You found the square root of both sides. So in the other hand, when you have s is equals to square root of 9 and you're trying to remove that square root, then you have to square both sides. When you square both sides, you see that it will now return back to the original form. So when that square root leaves 9, then it will turn to square for s. That's s squared is now equals to 9. So it's like you're going back and forth, the opposite. Do you understand this? This s squared is equals to 9 and s equals to the square root of 9 can be reversed to be s squared is equals to 9. That's s is equals to square root of 9 can be reversed to s squared equals to 9. Do you understand that? Okay. All right. So in the same vein, that's how we got this here. In the same vein. So if um sorry, if in the same vein, if m is equals to the square root of y, because said let m equals to the square root of y. So if m is equals to the square root of y, then to remove that square root from y, it means I have to square both sides. Then m squared will be equals to ordinary y. So that's how I got m squared is equals to y. I was actually reversing it. Okay, that being said, so if m squared is equals to y, then I can now come here and say this y, that y I have there. Remember, I have said that m squared is equals to y, meaning m squared is the same thing as y. So in the question, that y that I have there, since m squared is equals to y, then I can replace it as m squared. That y in the equation, y minus 11 root y. I can say since m squared is equals to y, meaning that m squared is equals to y, meaning they're the same. Like you can, substitute each other. Then instead of writing y, I'll say m squared. then minus 11. Since I said m is equals to root y, then in place of that root y, I can say minus 11m. That's because I said root y is the same thing as m. That's m is equals to root y. So I'm now substituting those values. So y is now substituted as m squared equals y. That's m squared because they're the same. Minus 11 root y. I said m equals root y. So I say minus 11m, then plus 24 is equals to 0. So you can see that that question that didn't look like a quadratic equation has now been turned into a proper quadratic equation. You can see the form as squared plus bs plus c. So the s in the general form, that's those your m you have there and stuff. You understand how I got this quadratic equation now? Do you guys understand how I got the quadratic equation? Okay. All right. So remember that you are actually looking for the letter. So now we're looking for M. So let's start. We're looking for M. So let's start and work with that. We're using same formula method. So you have to state what your A is. Remember, your A is that number that is attached to the S, the one with the square. In this case, it's not a square, it is M square. So whatever letter it is. But that number that is attached to the one is with the square, that is A. So here our A is 1. 1 is attached to M square. Then our B will be the number attached to M, that's the one to the ordinary letter without square. Our B is minus 11. Then C is that one that does not have any number, any letter. So our C is 24. So A is 1, B is minus 11, C is 24 from AS squared plus BS plus C. If you do not understand how I got A equals 1, B equals minus 11, C equals 24, then it's possible you were not in the class yesterday. So we looked at this in the preceding, yesterday or the day before, 2 days back actually. So we already looked at this at the time. Now we'll take these values and substitute them into the equation. So we'll say m equals to, so it's now m equals to, the reason is because in your equation it is m that you have as the letters. Normally we say the formula is s equals to. That's because when you're looking for s, so you say s equals to. But in this case, we'll say m equals 2 because in the equation we have m squared minus 11m plus 2, 24 equals 0. So you're looking for m actually. So m, not s, because there's no s here. So m equals to minus b. I told you guys, always write out the formula you want to use in solving so that you could be accumulating marks from there. So m is equals to minus b plus or minus square root of b squared minus 4ac over 2a. That's the formula you're using. Now all you have to do is substitute these values, the values of a, b, and c, into this formula. That becomes m is equals to minus b, that's minus bracket minus 11, minus b, so minus, and now b is minus 11. That's how you have those two minuses there. Minus bracket minus 11, then plus or minus square root of b squared. B is minus 11, so minus 11 squared. We talked about this the other day. I told you don't punch on your calculator minus 11 squared direct. It will give you a negative number as a result. So when you're using calculator, you have to minus 11 squared, you have to put it in a bracket minus 11, close the bracket, then raise about 2. Because what it means is minus 11 times minus 11. So minus times minus is plus. 11 times 11 is 121. So take note, because when you just punch it directly on your calculator, minus 11 square like this, it will give you minus 121, and that's not correct. That's because you left out the minus and you're only squaring 11. So the minus will still be there. So take note. That's why I put it in a bracket there, minus 11 close bracket square. Then s is minus 4 times a is 1 times c 24 in all over 2a, that's 2 times 1. Okay, so if we proceed, we'll have m is equals to minus times minus is positive. So this is 11 plus or minus square root of minus 11 to the power of 2 is 121. Then minus 4 times 1 is 4. And 4 times 24 is what? 4 times 24. 4 times 1, 4. 4 times 24. What's the result? What's the result of 4 times 24?
96.
Alright. So 96. Then over 2 times 1 is 2. So over 2. And now we have m is equals to 11 plus or minus 1 to 1 minus, this is 1 to 1 minus 96. 1 to 1 minus 96 is what?
25.
Okay, so m is equals to 11 plus or minus square root of 25 over 2. So when you get here, you can then have m is equals to 11 plus or minus square root of 25 is 5. So 11 plus or minus 5 over 2. Then when you're here, you can now separate them and say that m is equals to 11 plus 5 over 2, or m is equals to 11 minus 5 over 2. To have m is equals to 11 plus 5 over 2, or m is equals to 11 minus 5 over 2. Then doing that, here you have m is equals to 11 plus 5 is 16. 16 divided by 2 is, 16 divided by 2 is 8. Or m equals 11 minus 5 is 6. 6 divided by 2 is 3. So m is equals to 8, or m is equals to minus 3. These are the results. M is equals to 8, or m is equals to minus 3. Take note there. But then you will see, recall that we said that these are not the answers, because if you look at the actual question, you see that what you have there is y. What you have there is y. When you look at the actual question, what you have is y. So, and you're looking for y, not m. We only substituted m there so that we can have the actual quadratic equation. So those answers we have as m equals to whatever, they are not the answers. Now we'll go back and said, but we said that m is equals to square root of y. So you come back here. It is y that is in the actual question. So you see, but m is equals to the square root of y. That's this stuff I just showed you now, when we said let m equals to the square root of y. Yeah, so we've gotten the value of m now, good. But we said m is equals to the square root of y, and in the question itself, it is y that is there, not m. We're solving for y. So since m is equals to square root of y, and now we've gotten the value of m. So we can say m is equals to square root of y. That means m has two answers, right? When m is and when m is 3. So we can say that here, since m is equals to square root of y, we can say 8 is equals to square root of y, or this other one, 3 is equals to square 8 is equals to the square root of y, because it said m is equals to square root of y, and we have two answers for m. It's quadratic, obviously you have two answers. So when m is 8 and when m is 3. So since m is equals to the square root of y, then we can say 8, that's m, is equals to square root of y, or when m is 3, 3 is equals to square root of y. Then if 8 is equals to square root of y, the reverse will now be 8 squared is equals to y. Then this other side, or 3 squared is equals to y. When you do this, you have 64 is equals to y. That's y equals 64. Then when you do this side, you have 9 is equals to y. That's y is equals to 9. That's y is equals to 9. So look at this, guys. Do you guys understand this? That m you got is not the answer because you substituted. M wasn't in the original question. You assumed, you improvised. So after having m, you have to go back to where you said let m equals to the square root of y and resubstitute the m there. M is 8 equals square root of y. Then when you reverse it, remove that square root from y. You say find the square of both sides. So 8 squares equals to y. Then this other side, 3 squares equals to y. And when you do that, 8 squares is 64 equals y. So y is 64. Or the other side, y is 9. Do you guys understand this? Okay. Alright, so this is
So
a radical. Yeah, I'm listening. I'm listening. Someone was about asking a question.
which one is the real answer?
They said I didn't get you.
I said which one is the real answer? Is it the right question?
What's the real answer? There are two answers now. It's a quadratic equation. You always have two answers in quadratic equation. S equals this or S equals that. It's quadratic. You always have two answers. But that m you got, that m equals 8 or m equals 3 is not the answer because in the question, what the original question, what you have is y, not m. So that m, it was you who brought it in when you were trying to substitute. Since it's a radical equation, you are trying to substitute. That was why you brought m yourself. So what you originally have is y in the question in the equation. So bringing up that m by yourself, after having m, you said that let m equals to the square root of y. You said that let m equals to the square root of y. Then that means m squared is equals to y, obviously. So to now that you've gotten m as 8 or 3, then you have to get y because the actual question says y, not m. The m was brought by you. So you have to now get y. So you recall that you said m is equals to the square root of y. That means 8 is equals to, there are two answers for m. So the first one, m is equals to root y. So you say 8 is equals to root y, or 3 is equals to root y. Then when you find the square of both y, the square of both sides to get y, you have 8 squares equals to y. The other side you have 3 square is equals to y. 8 square is 64. 64 equals y. That's y is 64. Or 9 equals y. That's 3 square. 9 equals y. That's y equals 9. So those are the two answers. You don't have which one is the real answer. All quadratic equations always have two answers. Do you understand? Do you understand? Okay. So let's quickly look at example 2 before the time elapses. I think our exam is on Wednesday. This maths paper is on Wednesday next week. So it's almost here. So another question. Let's say you have what should we look at this time? Let's say we have um we've always done the ones where B was negative. Well, let's say we have this question D plus 10 root D and D plus 10 root D minus 24 equals to 0. So this is the question D plus 10 root D minus 24 is equals to 0. So take note that a quadratic equation is we're supposed to have AS plus BS plus C. But what we're having here now isn't quadratic, but we know that this could be quadratic, but as it stands, it isn't quadratic. Because in quadratic equation, we're supposed to have it in this form, AS squared plus BS plus C equals 0. That means we're supposed to have one that has square, a variable that has square, another one without square, and a constant that's one without any letter at all. But now what we have here isn't quadratic, but we can turn into quadratic. So we can say that let S is equals to the square root of D. Let S is equals to the square root of D. So if S is equals to the square root of D, then we can say that then S square is equal to D. That's when you reverse it. You say let S equals to the square root of D. That's that one with the square root. Let S equals to the square root of D. It's exactly the same thing you did in example 1. Let S equals to the square root of D. If S equals to the square root of D, then to get the value of D, you have to square both sides. That means you say then S squared is equals to D. And if you have that, then you can now substitute it into that equation. And what you have, that D you're seeing there, since you said S squared is equals to D, and that D is now S squared plus this 10 root D. You said root D stands for S, that's S is equals to root D. So S squared plus 10S, then minus 24 equals to 0. So you just substituted that D plus 10 root D minus 24 equals 0. That's what we've written as S squared because it said S squared equals to D. That means you can substitute it. So that D in the original equation is now represented with S squared since S squared is equals to D. S squared plus that 10 root D is now represented as 10S because it said S is equals to root D. Then minus 24 equals 0. When you get to this stage, then you can now again pick out your A, B, C. So A is a number attached to S squared, which happens to be 1 here. It is not always like this. These questions are just coincidentally like that. So if there is a number, maybe you have 2S squared now. Okay, we did those on Tuesday, sir. You have 2S squared now, that means your A would have been 2 because the A is a number at the back of the S, the S square rather. The A is a number at the back of the S square. That's coefficient of S square. You can look at it here in this general form. Let me circle it out with red. You can look at it here for me. So the one behind the one with S square is A, the number behind. The number behind the one with ordinary S is a B. The last one without a letter is a C. So then that our A here is now 1, then the B is 10, that's plus 10, positive 10. C is minus 24. So if we are to solve this, recall that, don't forget, always write out the formula you're using. Recall that S is equals to minus B plus or minus square root of B square minus 4AC over 2A. So that's the formula you're using. So now we substitute what we have into that. We have S is equals to minus B. That's minus, our B is 10, so minus 10 plus or minus square root of B square. B square is 10. And yeah, B is 10. So 10 square minus 4 times A is 1 times C is minus 24 minus 24. So all over 2A. All over 2A. That's all over 2 times 1 because A is 1. Proceeding, we now have that S is equals to minus 10 plus or minus 10 to the power of 2 is 100. 100 minus 4 times 1. You have 4 times 1 is 4. Then 4 times minus 24. That's minus 96. And all over 2 times 1 is 2. And next we say that S is equals to minus 10 plus or minus, that's 100. And minus minus there will give you plus. So plus 96 over 2. Does everybody understand how I got to this stage I am presently? Okay, okay. So continuing, we would have that S is equals to minus 10 plus or minus 100 plus 96, that's 196 over 2. And when we look for the square root of 196, we have S is equals to minus 10 plus or minus. Take note that unlike before, before that your minus B part, this part here, this part I want to circle the red now. This part before you used to say, when we write this part, we say minus times minus. That's what to say minus bracket minus something. That's because in the formula it says minus B. That's the second part. Then maybe your B now carries another minus again. That's why we're writing two minuses. But in this case, that minus B minus and B is now 10, pure 10, not minus 10. That's why we did not write it bracket minus again this time. It was just one minus, the minus in the formula because B is positive. So take note, it is when the B carries minus, that's when you now have two minuses because one minus from the formula, one minus from the value of B. That makes it 2. But in this case, B is pure 10, just positive 10. That's why I have minus 10 there. And we're not able to cancel, say, minus times minus. Okay, so coming back here, minus 10 plus or minus the square root of 196 is 14, 14 I think. Square root of 196 is 14, then over 2. You see, so we have S equals minus 10 plus or minus 14 over 2. When you get to this stage, then you can separate them and say that S is equals to minus 10 plus 14 over plus 14 minus 10 plus 14 over 2. That's minus 10 plus 14 over 2, or S is equals to minus 10 minus 14 over 2. Then doing that, you have S to be equals to minus 10 plus 14 is 14. Oh, sorry. Minus 10 plus 14 is 4. I meant 4 over 2, or S is equals to minus 10 minus 14 is minus 24. Minus 24 over 2. So last term, S is equals to 4 over 2 would be 2, or S is equals to minus 24 over 2 would be minus 12. So these are the values of S. S is equals to 2, or S is equals to minus 12. But again, remember, the actual doesn't contain S. The actual question does not carry S. It was you and I that brought in this S because the actual question wasn't quadratic, and we now had to improvise to change it to quadratic. Look at the actual question. It is D plus 10 root D minus 24 equals to 0. So the actual question doesn't carry S. So those answers you got now, they are the values for S. So, but if you remember, introducing the S, it said let S stand for root D. Let S stand for root D. So we'll come here, come back here, because we're not looking for S, we're looking for D. That's what we have in the question. So we come back here and say that, but we said that S is equals to the square root of D. And if S is equals to square root of D, if we reverse this, that means S squared is equals to D. If S is equals to the square root of D, that means S squared is equals to D. When we reverse it, that's when we square both sides in order to get the value for D. Then we can now start putting those values of S and see the result we have. Remember, S is equals to 2, or S is equals to minus 12. So we can now say, since S squared is equals to D, we can now say 2 squared is equals to D, or minus is equals to D, because S is 2 or S is minus 12. S is 2 or S is minus 12. So if S is equals to square root of D, which means that S squared is equals to D, then we can now put that and say 2 squared is equals to D, or minus 12 squared is equals to D. Please take note, like I told you, when you're dealing with this, always put this in a bracket. A number that carries minus, when you're looking for the square, put it in a bracket so that you don't go and write a wrong answer. Because if you're looking at it like that, if you just say minus 12 square without bracket, it will be giving you minus 144. Even when you use your calculator, look at what I'm trying to say. If you say minus 12 square, the answer it will give you is minus 4. So that's why you put it in a bracket so that the calculator will give you the correct answer. So when you do that, 2 square will now be equals to 4 equals to D, meaning D is equals to 4. Or, yeah, minus 12 to the power of 2 is 144 equals to D, meaning D is equals to 144. So these are the answers. D is equals to 4, or D is equals to 144. So remember, that number, that letter you introduced by yourself, the answer it will give to you is not the real answer. You still have to go back and substitute those values into the that first substitution you made. So the S was introduced. That's why we still have to go back, or we're looking for D. Look at the actual question was D and not S. So that S, we brought it ourselves. So after getting the value of S, go back and substitute that value of S into that improvision we made from the onset. And then we now got the actual value of D as D equals to 4, or D equals to 144. And since it's quadratic, like the question someone asked, I think that was Rina, since it's quadratic, you always have two answers in quadratic equations. You always have two answers. S equals this or S equals to that. Do you guys understand all that we've done here today? Do you guys understand how we've done here today? All right. So, do you have any questions so far? Do you guys have any question looking at this? Do you have any question dealing with a radical equation now? Any question? All right. So, in the absence of any question, having done these two examples for radical equations involving quadratic equations, then we can say that we'll end the class until, okay. We know you're just coming back. I was asking, is there any question? Do you have any questions so far?
So,
Okay, so in the question, we can end the class here until next time. So you guys take care of yourself, and I'm wishing you the best and stay safe as well. So bye for now.